about agentic AI. So there are two portions of it. Number one is on the aspect of strategy towards the scalable deployment in terms of roadmap, what type of agentic AI, what are the types of agentic AI, and importantly, XOps. Because when you are deploying agentic AI solutions in a production environment that will be scalable to be used for manufacturing or automotive or supply chain, warehouse, or any industry sector, you have to consider XOps. So what is XOps? XOps is your DevOps pipeline where you are doing the development, which is continuous integration, continuous delivery, continuous testing, continuous deployment, continuous monitoring, and also continuous security. So apart from DevOps, because the data is real time, or you are having a time series data coming from different sources, so you need to have an automation also on the data transformation journey. That data transformation journey is from ingestion, cleaning, transformation, and towards your either descriptive or diagnostic analytics pipeline or towards artificial intelligence, predictive using machine learning, deep learning, and also you have an NLP, large language model, and agentic AI solution. So you need to have an automation on that. That is your data ops. We will study on that. And next will be on AI ops automation. So AI ops, you have a model training, model testing, model deployment, model monitoring, and this environment and this cycle is continuous. That is part of your AI ops. So your DevSec ops, your data ops, and your AI ops combine together to form X ops, which is an important aspect of any AI application development, testing, and deployment in a production line. Okay. Without further ado, let me start my presentation. So what is agentic AI? Agentic AI generally refers to an AI system that possesses the capability to make autonomous decisions and take action to achieve specific goal with limited or no direct human intervention. There is a quite much confusion when I'm communicating with different stakeholders, whether they are students, academicians, or industrial practitioner. The notion of understanding what is agentic AI or AI agents are different. And many of the stakeholders think that they are same. They are not same. So agentic AI's application may consist of one or more than one AI agents. So one and more than one AI agents work together to form a system. That system is your agentic AI system. So the key aspect of agentic AI system is number one, autonomy. Without human intervention, very less or no human intervention. So they can able to work together. And in agentic AI system, you have a big task that is broken down into smaller set of tasks. Those smaller set of tasks are having a specific notion, which has been done by one AI agents. An agentic AI system can also operate independently, making decisions based on their programming, learning, and environment input. So environment input are the real-time data coming from different sources. Those sources can be from machines. Machine in manufacturing can be PLC, SCADA, MES system, or DCS system, or IoT system. Learning means that we are also using reinforcement learning. In the reinforcement learning, you will able to have decisions. If the AI is making a decision which is correct, it will be giving itself a point. If the decision is wrong, then it will be giving itself a negative point. So there is a reinforcement learning. Those reinforcement learning depends on type of new data coming for different scenarios or different decisions that has been made in the passage of time. And because it's real time data, which is coming from hundreds of different sources at the same time, especially in manufacturing ecosystem. So there can be different departments, the department from finance, from HR, from production planning, from production engineering, from QA inspection, from sales, marketing, and others. Now, Number two is goal oriented. For every aspect of agentic AI system, they have a goal to achieve. That goal is a task, and the task has to be achieved, means it has to be successful. So these AI agents are designed to pursue specific objective, optimizing their action to achieve the desired outcome. There are many theoretical aspects of those theoretical aspect of ecosystem where there are different form factor, how they will gauge that they have achieved the task or not. So not only it's on yes or no kind of a situation where they will be achieving a task or not, but they will also look into what is the most optimal way and what is more optimized way to do the task with a less resource utilization, less time constraint, and more accuracy. Then environment interaction. Those AI agent can interact with within other agents or with the humans or with the system to adopt and dynamically change the scenario based on different ecosystem. This means they are scalable. They are having a learning capability. It's not fixed if else condition that this thing happened, they will do this thing. Instead, they are having a learning capability using machine learning, reinforcement learning to improve their performance over time. Just like humans, if we do something new, we may take some time, but if we have done this couple of times before, then we will be quite efficient because we have utilized our knowledge before having an experience. They have a workflow optimization. So workflows are the steps to perform certain tasks to achieve a goal. So they can able to not only follow those work steps, but dynamically arrange those work steps in terms of completing the task, and importantly, optimize optimize the workflow in terms of utilization. So those agentic AI solutions can enhance the business process, even integrating the language understanding with the reasoning, planning, and decisions. So language means that right now in many of the factories or organization, they may have different time zone based on where their branches are, and then the language itself may be changed. Some may be using Bahasa English, some may be using Bahasa Malaysia. So they can able to understand those language and extract the meaning out of it, reason with themselves, plan accordingly, and do the decision making without even disturbing humans. But definitely there are some concerns regarding the ethics of AI, governance of AI, and also importantly how we can able to not independently deploy on the production line because the risk is too much. AI system can never be perfect. There may be an accuracy of 99% or 96%, but that 96% and having a 4% improvement will be always there. And you cannot able to autonomously making them operate on the production environment. Still, it is ongoing research going on right now by academic scientists, industrial practitioner to create a sandbox. And those sandbox are basically for them to improve or experiment the existing small ecosystem towards a bigger ecosystem in terms of scalability. So one of the biggest concern is we never deploy independent agentic AI, not because they are not capable of, we can able to make them capable, but with the new condition coming in, which they were not being trained. So they will make a mistake like human. And we don't want them to make a mistake that will able to increase the chance of disaster. So to minimize the risk management, in some areas in the production line, we will able to deploy, but in many areas we don't deploy. We do the deployment in the operation level for the time being. And then optimizing those resource allocation, communication within themselves and with the system, collaboration and integration and automation towards the ecosystem. And multi-agents and the system conversation, because agentic AI can able to consist of multi AI agents. So how they can able to nominate the leader within the agentic AI system, and how they will able to have a decision making and also integration with the tools. That are the key aspect of agentic AI system. Okay. So agentic AI offered 20-fold increase in productivity. That is a very good number in terms of, or should I say, quantifiable number for the industry practitioner to implement. But definitely, it will. There are some hidden costs. For example, human will able to subject matter expert perform a task is 1x. If they are using Gen AI, they increase the productivity by 1.2. If they are using AI agents, not agentic AI system, AI agents, they can able to increase the productivity by 2%. But with using an agentic AI system, they can able to have 20-fold increase in productivity that can build and supervise a virtual organization if needed human input. I have taken this slide information from McKinsey and Co, which is very good, very attractive. But what are the hidden costs? Hidden cost is development cost. You need to develop agentic AI system. Dalam Malaysia, other agentic AI engineers, very less because it's still evolving. And when you wanted to develop, it will take some time and resources. So this means you need to hire many people. Number three is when you wanted to run this on a system, where the system will be residing. Will you be creating your own framework or will you be using your existing framework? If you are using existing framework, where you're planning to deploy? In the cloud or in the server? In the cloud, okay, then you have to use some managed services to develop those agentic AI system. And those managed services will be not free, they are costly. And when you want to run the model, train the model, test the model, and run the model, it will be utilizing enormous amount of resources. So that's why they are expensive. Expensive to develop, expensive to maintain, expensive to improve. And then those expenses, which is part of your capex and opex, and the value creation is still not that much higher as well in this regard. So use cases in manufacturing, for example, are one of the most important sector in the world where the transformation is happening quite much rapidly. And that rapid transformation pave the way for innovation using new technologies so we can able to create a value in the end-to-end ecosystem. Agentic AI is also one of the system or transformative system or emerging technology within the AI domain and landscape that can able to create a value proposition. That value proposition are mostly being quantifiable number that can bring the way towards uh, return of investment, ROI, or RODI, which is return of digital investment in the form of percentage that can able to help us gauge how much value creation has been done. So predictive maintenance and asset optimization. We have a predictive maintenance using traditional machine learning. If the parameters are not complex, if the parameters are quite much complex, and there's a relationship where they will have a hyper connected factory. Hyper connected factory means that there are different type of machines or sensors which are connected using different technologies, and you are basically extracting and managing that hyper connected factories. Then machine learning itself is not enough, so you need to have a deep learning based system for your structured, semi-structured, or unstructured data. So agentic AI solutions can able to facilitate us in terms of predictive maintenance and asset optimization for the factories. Now, which factory? Is it a small SME? No. Small SME does not have that much enough machines that can create a value, a proposition for your agentic AI system. So it will be either LLC, large local large companies, or GLCs or MNCs. Product quality and defect detection, it can also be done not only identifying the defect. You can use deep learning model, whether it's YOLO, whether it's RNN, faster RNN, or CNN or GNN, to identify the defect. But what's next? Is it only to identify defect only? It doesn't make sense. We need to have a identification of the defects, number one. Number two, we need to also understand why this defect took place in the first place. Number three, we need to go reverse engineering, going back towards the previous process steps, which is called traceability, to trace what are the factors that produces those defects and how we can minimize it. We cannot eliminate it, but we can minimize it. And that agentic AI system can able to work with us to do the descriptive diagnostic and predictive analytics understanding towards the rectification on the recommendation for the prescriptive analytics. Autonomous robots, you have seen in Nasikandar, a small one, but in the factory environment, they are very complex because they have to bring a lot of different things. It's not showing slide.
There's some technical issue. Mr. Dr. Imran going to be joining soon.
Sorry, can you hear me? Sorry for the technical issue. My Mac crashed. Apple, right? Let me try to share. Can you able to see my screen? Okay. Sorry for the inconvenience caused. Okay, so I have to uh, restart. Okay, so I was telling that agentic AI system in manufacturing can be used for AI power production efficiency, not only to identify the defect, but also to rectify it, give a recommendation how we can able to minimize it. And then also for the self-optimizing production lines and also supply chain, and then ensuring compliance with the intelligence system, basically. Is it showing now? I, I'm trying to share the entire screen. Allow. Is it sharing now? Okay. Is it okay? Okay. Okay, so what are the agentic system and how to build AI agents? So for the AI agent, when you wanted to build, you must need to have a purpose and scope. Uh, when I was discussing with a couple of stakeholders in the industry, they have an unrealistic purpose. They say, okay, I want AI agent agentic system to manage my whole department. It has to be specific. It cannot able to 100% replace the human for the time being because you need to build it from the scratch or build it on top of existing framework. So you need to have a use case. So each department have hundreds of use case. You need to select the department that is more manual that you would like to give it to assign to your agentic AI system. And then also what are the needs of the user? What is the success criteria? How do you measure the success criteria after you implement? Will it be having enough basically resources for you to develop, and once you develop the investment that you require and the saving you got, are they match the expectations? And also the constraints are, what are the constraints that you may face while developing an agentic AI system? Okay, number two is to system prompt design, means what are the goal that what you wanted to achieve, and what is the role that agentic AI system will play. For example, assistant HR executive, or assistant technician, or operators, or IT person. What are the role and persona? So persona is basically the step the person will able to, the role and the person will able to do when they enter the organization. So you have a human, they will able to come to office every day, morning 9 a.m. until 6 p.m. What are the things that person do? All of those steps are the personas, and then you have to map the use case based on that persona. And then what are the instruction and guardrails that you need to consider? Number three is importantly, agentic AI system use large language model. So which LLM you would like to use? What is the base model? What are the parameters that you will be using? What are the context window and also the cost and latency? Cost is very important. I have seen many agentic AI system failed because they didn't consider about the realistic cost that they have to bear when running and developing and maintaining those agentic AI systems. And then memory. So do you have enough memory and resources in terms of running those sandbox? You don't build the agentic AI system on the production line rather than you will do with the sandbox first. And then from there, you will able to which tools you will be using. Will it be API-based integration, MCP server, AI agent as a tool and custom function, moving towards orchestration? For the orchestration, what are the root trigger parameters that you are looking into? What are the user interface? Is it mobile application based or web based? And then last is what are the testing metrics that you will be having? So AI agent lifecycle, importantly, this is a very important slide. AI agent lifecycle is basically 5 steps. So your AI agent, when they are running, they will be performing those 5 steps, which is perception, cognition, decision, action, and learning. They can be reversed or interchangeable, but these are the 5 important steps basically we do. So let's look into that one. For example, perception. Perception is how AI takes in the world, how they will be doing in the real world environment of manufacturing, automotive supply chain, or in your enterprise or your office. What will be their role looks like? Knowledge. Knowledge is the brain. What is the decision brain that they will be having all of the information. Number 3 is reasoning, which is AI problem solving engine. Number 4 is learning, learning from the code, from the new data, new scenarios. And number 5 is action, taking an action. Let's go deeper inside. Perceptions are the data coming from different landscape. They can be IoT sensors, they can be databases, they can be devices, they can be robots. All of the data coming and ingested by your agentic AI system is the perception, the real world perception. Then data filtering. Data filtering is remove the noise. You need to clean the data. That cleaning the data is removing the noise. Noise are the outliers. Outliers are the wrong value which are being saved or produced while transforming those data or transferring the data or with the manual intervention or machine having a sensor giving a wrong data itself. Or format, improve the quality of the data. Number 2 is on the data transformation, converting into a standardization format following the data governance. Number 3 is the feature extraction, which is identifying relevant features or pattern in the data. So this is the perception. So you need to think the input data, that data coming from also humans. Human can also give a data. For example, if you have an agentic AI system that can able to do the job posting from the organization and collect the CV, and then from the CV, it is getting filtering that CV most relevant based on some keywords in the CV and phrases and also experience, relevant skills. So the input over here is the PDF file. So it has to have an ability like OCR to read those content of the PDF file. And then those content needs to go towards the knowledge, which I will be discussing later. So input is the most important and essential element in an agentic AI system, which is perception. Number 2 is knowledge. So the knowledge can be representation, acquisition, and memory management, where knowledge base and memory components enable AI agents to reason, learn, and output, and then improve decision making, enhance adaptability, and increase autonomy. Number 3 is reasoning. Reasoning is basically the AI problem solving engine, which is interference engine. Some AI agents include dedicated inference mechanism to draw conclusions, particularly in rule-based symbolic systems we will study later, and also optimize some algorithm as well. So employ the techniques such as decision trees, neural network, and optimization algorithm. Last is the learning part where the code meets consciousness, component that learn by mathematical trial and error, center that makes machine learning so exciting, and then also learning mechanism for AI in terms of reinforcement learning to make an autonomous, actionable intelligence or insights. Lastly is basically on the transforming, which is taking an action. By the way, I will be asking one question at the end of the presentation, where the large language model will be residing. Will it be in knowledge, reasoning, or learning? That is the question that I will be asking later. Okay. So there are a couple of types of AI agents. Simple reflex agent, which are making instant decisions. There is no rule, there is no memory. It's learning. For example, giving what is the weather condition in Kuala Lumpur? What is 2 plus 5 equals to? What is the long mathematical equation that they can able to solve and give an answer? It doesn't require any databases. It doesn't require any information from large language model. So that is a simple reflex agent. The second one is a model-based reflex agent. So the model-based reflex agents are maintain internal environment, allowing context-aware reasoning, improve decision making compared to simple rule-based agents. And number three is a goal-based. Goal-based means that they have a database, they have a knowledge base to achieve a goal in terms of extracting the information from large language model. Then number four is compare a utility-based agent, which is compare action outcome using utility function. Those utility function will able to gauge whether the action created or done by the AI agent is good enough or not. They can able to have a scoring system from 1 to 10. If the score is high, there will be a satisfaction. If score is low, then they will able to do the re-improvement, and with the continuous re-improvement using the reinforcement learning model for machine learning and deep learning, they will able to get more input from the large language model to improve the decision and also doing the action based on the decision. So there will be a repetitive improvement, which is called CI, continuous improvement for the AI agents. Number three is learning agents. Learning agents are basically continuous modifying behavior through experience feedback, self-training to improve decision-making accuracy over time. And there is MAS, which is multi-agent system, which is multiple autonomous agents collaborate or compete, sharing information to accomplish complex tasks. So MAS, the one important thing, MAS, which is multi-agent system, are working on one particular task. They are not working on multiple tasks at the same time as part of agentic AI solutions and umbrella. So agentic AI solution or system will have these agents working together, but the MAS specifically will not be working with other agents rather than within its own agents to solve one complex or big problem. Okay, let's go deeper level into the AI agent. Later on, Mr. Arshad will be doing the hands-on. Simple reflex agent. So simple reflex agent react instantly. Number one, it always react instantly using if else rules based on current sensor input. Some people say that they are not AI agents at all because they are just based on the rule base. To me, they can consider AI agent. Why? Because they can collaborate with other type of AI agents to work together and basically modify their input and also modify their working. They have no memory, no ability, but work best in a simple predictive environment. They are considered as AI agent within the agentic AI system. How does it works? For example, how do they work? Let's go deeper to understand further. Let's say there is an IoT sensor. That IoT sensor is being placed in the production environment of a factory. Its main job is to check the environment state. The environment can be within a machine where there is a threshold of a temperature, or it can be outside of the machine. So they need to check the humidity factor, the temperature factor, the wind factor, and other factors. Now, agent check if the condition of that particular environment is maintaining a particular threshold or value, then it will able to execute some task. So those are rule-based trigger actions. And then based on that, does not consider history, goal, or future consequences because they don't have any memory. You need to have a memory to consider historical facts, historical data, or historical incident. They will be just looking into agent in terms of specific task that does not require past or future data. Okay, it's a repetitive process, and they can able to have a logic in terms of perception, which is getting the data, rule matching, and action. So from those five, we are just taking three. Example can be temperature. If there is a temperature on, if there is a temperature below that, it will be off, for example. Use cases in manufacturing in Industry 4.0. Example is conveyor belt object detection. Now, object detection. Object detection is detecting an object using deep learning, which is part of that system, for example. So if the sensor detect an object at a position X, then activate a robotic arm. For example, if there is a defect, activate the robotic arm to discard that particular manufactured product. If it is not defect, then the robotic arm will not be done. That is why it is AI agent. And another example is safety light curtain. If the beam is broken, stop the machine. If the beam is clear, then continue the operation. Example three is PLC-based rejection mechanism in manufacturing, where in this example, if the quality sensor show fail, push product to the reject bin. If pass, continue in the conveyor belt. Okay, so these are some of the example of simple reflex agent within the agentic AI system. What are the advantages and limitation? Advantage is fast decision making, simple, reliable, low computation cost, easy to program, maintain, and ideal for well-defined repetitive tasks. What are the limitations? No learning, because there's no memory, and based on no memory, they are not suitable for complex tasks and limited intelligence. Number two, second agentic AI system is called model-based reflex agents. So in the model-based reflex agent, the user will able to input some data. Internal memory will be understanding that data and upgrade the internal state based on some particular rules, and then able to change some condition which is formed as an actions. For example, if you have a autonomous vacuum robot, they will able to remember, map your area. Those mapping the area will be saved in the form of coordinates in the memory. So they will able to know which places are objects, which places are not objects, so they can able to maneuver or go around easily. Okay. And then if they able to see some spot of dirt using their AI models, using deep learning models, then they can able to clean it. Okay. Um, Examples in the manufacturing is a predictive material routing. So in the autonomous or semi-autonomous factories right now, there is a AGV or AMR. Those machines are uh, taking the materials or parts to a different station of a production line without human intervention. Okay, they are using that. Condition monitoring is another example, and also smart quality inspection using deep learning is another example. The advantages are handle partial visibility using memory. They are making a smart decision, can infer a lot of states, but having a limitation, they cannot able to perform some complex task. Okay. Third, AI agent as a part of agentic AI system is a goal-based. They are more complex and sophisticated as compared to previous AI agents, which is so this is goal-oriented, making a decision specifically to achieve a goal or milestone. Instead of reacting instantly, they use reasoning, planning to create an action that have a desired outcome based on the achievement of the goal. They are flexible, handling complex tasks, and they are multi-step tasks as compared to previous base AI agents. So the flow is goal. They have a goal. That goal can be integrated in them by human intervention, by inputting the data, or by system itself. Then they will have a perception. The data from the perception, they will have a reasoning, planning, action, and they will reevaluate, and then the cycle will be improved. The use case is also AGV arm assembly, robotic arm assembly, and also energy optimization, how we can able to utilize the energy to reduce the carbon blueprint as part of the ESG ecosystem in a factory. Advantage, they can able to have, they are more intelligence, can handle complex tasks. Limitation are they are not that much strong in terms of reasoning. The second last AI agents are utility based, which are more complex than the previous one because they are having a measuring outcome. Previous one was having an outcome, but the outcome is quality based or not quality based. They don't care. But here they would like to maintain a quality of the action that they will be performing. So those action can able to help in the form of a utility score, whether it is a happiness, efficiency, cost, safety, or other metrics depending on the use cases itself. The flow is perception, evaluate action, choose highest utility, and then act and then reevaluate. Self-driving car is an example. In manufacturing, for example, intelligent schedule systems. The schedule are based on production planning. The production planning is based on the demand of the market. If the demand is high, demand is low, they will able to be intelligent enough to create a value chain within the factory. Energy optimization for the machines to calculate the energy saving, and also adaptive quality inspection to auto reject or escalate itself. It has advantages and disadvantages that they are more complex. They can able to do multiple, they can evaluate the outcome based on the quality, and the limitation is this that they are computational intensive. They require heavy CPU and GPU, and then also memory as well as a hard disk for the retraining in this regard. Okay. Learning agents are basically improving with the passage of time based on the experience and feedback. Feedback can be within the system or within the data or from the humans. They will be having a scoring. The perception is based on actions, feedback reward, knowledge, better action, and also in this regard towards the action. So perception, action, feedback, update the knowledge based on the action before to reevaluate or improve the decision, and then they will able to go in the cycle. Robotic robot learning to pick up different objects autonomously instead of scripting. They can able to have a computer vision to check the dimension of an object and then grab those things based on the shape. Is basically an example of learning agents. Example is predictive maintenance model with more complex data, adaptive quality inspection, and also autonomous process optimization are part of this thing as well. Okay, we'll skip that. So there are many agentic AI framework. LangChain, LangGraph, QAI is the most among them is the most famous one. So LangChain is basically chain and agents abstraction. They are having a multi-LLM integration, multi-LLM integration that they are integrating with existing large language model, whether from OpenAI or others. They have a good memory management, prompt engineering capability, and also integration of API and web scraping to support. Advantage is flexible. And the app easy to integrate, having a big community and scalable. Applications are conversational AI, autonomous system, document analysis, and code generation. LangGraph is basically more stateful, having workflow, multi-agent coordination, bit complex as computer land chain, and they handle the complex stateful AI and dynamic workflow. Application can be interactive storytelling, multi-step chatbot, and gaming, and also decision making. Crew AI is role-based AI with the task planning, team structure, data execution, and conflict resolution. They are modular-based environment, having an ecosystem for which is scalable and decision optimization. Application includes the project simulation, business strategy, and creative writing, and in healthcare as well. So if you wanted to understand the challenges, it's quite deeper. I think we have less time. I have 10 to 15 minutes before we proceed with this. So when we are considering the challenges for agentic AI system, there are a couple of important challenges that we need to look into. Number one is memory poisoning. Memory poisoning is basically malicious input, means the wrong data is inputting, wrong information is being fed to the AI agents that can able to affect the accuracy of the actions of the AI agentic AI system. That is called memory poisoning. Examples can be input. There's no input validation implemented in your front end, and there is no input validation from the IoT system before it will digest it to the agentic AI system. So these are some examples. Affect. There are many teams that can be affected based on this challenge, and how to detect that. We can detect that using audit logs and also anomaly alert as part of your AI ops ecosystem continuous monitoring. Business impact can be data leakage or service failure because the wrong data has been input that will affect the accuracy of the system itself. Tool misuse, how abusing integration and also API. Some example are guardrail runtime checks. Who are the stakeholders, which are DevOps security vendors are the stakeholder, and how we can able to detect by automating the API monitoring. Other challenges are privilege compromise. If you don't implement IAM, identity and access management, that can lead to security mismatch and problems. Data quality issue. If you don't clean the data properly before inputting in the in the system. Now, there's a difference between memory poisoning where there is a wrong data, but in data quality issue is this there is a data which is okay, but they may have anomalies or having some spaces or some other ecosystem. Unrealistic expectation is also a challenge because managers or the senior management will think that AI agents can do wonders and replace human. It's not like that. Okay, governance gap, workflow failures, and task complexity and human manipulations are some of the real world challenges while we are developing agentic AI. You can take a screenshot, and I think the team will able to send the slides as well. Okay. Some of the real world case study before we conclude, real world case study for manufacturing, for example, Siemens. Siemens is using the agentic AI system to transform its maintenance operations by deploying AI model that analyze sensor data from machinery. So they do the analysis of the data, and then the system will predict the equipment failure before they occur, and then schedule the maintenance. So they are steps. So every step they are doing artificial intelligence value creation, and then that value creation output is being given to the next step. That will also do some AI enabled application to do something and give it to the next step. And then from there, they are providing a holistic equipment health overview and proactive maintenance orchestration as well. Okay. So for the technology stack, they are using regression models and deep learning. So in multiple AI agents, they are using different AI tools that are performing some tasks. And those tasks is basically workflow for the bigger task. Okay. Financial impact is basically using maintenance costs to 20% revenue growth for 15%. They will be using large language models as part of the system to basically make some decision making. Okay. Transportation, DHL, is basically using AI model to predict the orchestrate shipping demand, number one. Then based on the output, doing optimized route. And then from there, doing the manage the warehouse operation. So warehouse operations are very complex because there are hundreds of operations that needs to be conducted in the warehouse based on the process data from various sources, traffic patterns, weather condition, and order fulfillment volume on that. Okay. And lastly is on the energy. In energy, they are BP, British Petroleum, are analyzing the seismic data, and those seismic data generate a 3D model to subterraneate the structure. Multi-model approach combines the geological, geophysical, and historical data to identify favorable drilling sites and orchestration its regard. I have many uh, case studies, but I think we have less time, so I have prepared. But I will share with you later on that. Okay, these are the 10 modern AI agents protocol, which is manager friendly list. IBM have ACP, in AGP, Google have A2A, Anthropic is having MCP, LangChain is having DAP, open source is having community is having OAP, which is Open Agent Protocol. RDF is from Semantic Web. Agent OS is proprietary. TDF from Stanford University, and FCP is from OpenAI. To my humble understanding, LangChain, LangGraph, AutoGen, and QAI are one of the most widely used LLM framework that is utilized by agentic AI system. So LangGraph will be graph-based, workflow-driven architecture. LangChain will be developer-friendly LLM app building. Autogen is conversational multi-agent orchestration, and Crew AI is role-based agent coordination. Now, coming back to the last part, I have less time. The last part is once you have all of this information in place, how you will be doing the development and also making a part of your CI/CD ecosystem. So there are pipeline where you will be develop, improve, maintain, and monitor. That pipeline is very essential. You don't develop an AI agent as a monolithic. You are doing it as a microservices-based architecture, and those architecture require a proper continuous integration, continuous delivery, continuous testing, continuous deployment, continuous monitoring ecosystem, which is part of DevOps. But apart from DevOps, there are a lot of automation required in terms of new code, testing, delivery, deployment. So deployment, you have a dev environment, staging environment, and production environment, and it has to be continuous. So in the previous days, what we do, we have a big monolithic applications. Some people are still doing it. So if you change little piece of code, you need to build the whole application that will take a couple of hours. But in the modular based architecture, you just need to build that specific module. So you don't have to disrupt every other thing and redeploy. So automation is very important, especially if you have a hybrid multi-cloud architecture where you're using on-premise server, sandbox, or also basically you are using cloud, one cloud or multiple cloud. Whether you are using on-premise or cloud or multi-cloud, you need these pipelines for your repeatability, scalability, and also automation. Those pipelines can be data ops from your data ecosystem, from data ingestion. If you remember perception, data ingestion, cleaning, transformation, and giving to the model. DevOps is for your end-to-end code-based delivery, integration, deployment, monitoring. ML ops and AI ops, model ops are for AI model ecosystem where you are doing the data annotation, training the model, testing the model, deploying the model, and monitoring the model. Your SecOps is for your cybersecurity operations, from threat modeling to static application security testing, dynamic application security testing. And then you are having penetration testing, RASP, and also SIME. BizOps is for your business operation. Cloud Ops is for your cloud end-to-end operations. And then FinOps is your financial operations. So when you combine all of them, you are having an XOps ecosystem. And those XOps ecosystem are basically for different ecosystem. So agentic AI system, you definitely need to have a DevSecOps for your continuous integration, continuous testing and deployment and delivery, whatever. And then you also need to have DevOps, AI ops, but before AI, we need to have a data ops to streamline your data process automation and collaboration to feed the data to your agentic AI system. AI ops is a part of your improvement of AI agents within the agentic AI system. So when you are improving the AI agents itself, you also need to maintain the version number. Many people are having a version number of code versioning, but you also need to have a data versioning, and you also need to have an AI versioning, AI model versioning. So agentic AI system will have AI agents. Each AI agent have a code-based versioning, and also their model-based versioning as well, which is part of your AI ops ecosystem. So in the DevOps, you plan, develop, build, test, release, deploy, operate, and monitor. So this is the flow for continuous integration, delivery, deployment, testing, and operation that I have discussed before. And there are multiple tools which are used. For example, for planning, you can able to use Jira. For developing of the code, you're using Visual Studio Code. For building, you can use a build, Visual Studio Code, or Maven. And for integration, you are using Jenkins or GitHub Actions. For testing, you can able to use Kotlin or Selenium. For releasing, you have a release. So infrastructure as a code, IAC, you can use Ansible or Terraform. For deployment on the container, you can use Docker. For the deployment in terms of clustering, you can able to use Kubernetes itself, but you need a service for that. And then also for the monitoring, you can able to use ELK, Prometheus, or Datadog in terms of monitoring of not only your large language models or agent AI system, but also the resources that they are using. Okay, so these are some of the tools that we are using in the DevOps pipeline. In agentic AI and DevOps tools, how they can able to integrate. For intelligent code integration, GitHub Action, GitLab CI, or Bitbucket pipeline. Okay. Autonomous build and compilation of automation, we use Jenkins. Adaptive testing, I mentioned Selenium before. AI-driven deployment, we can be able to use Agro CD or Octopus. Predictive release management and change control, we can use Microsoft Release Management, Harness, or Launch Darkly. And then proactive monitoring in terms of healing, we use Datadog or Prometheus for the monitoring. In terms of continuous security and unit testing automation, my favorite is SonarQube. Automated feedback loops, anomaly detection, we can able to use Ops Genie. Resource allocation and infrastructure in terms of dynamic, you can able to use Terraform or Ansible with Kubernetes hosted on your local server, or it can be on the cloud, which is AWS or Microsoft Azure. And then also for the knowledge management and developer assistance, you can able to use Stack Overflow for the team or GitHub Copilot, which is very good. And then data-driven insight for pipeline optimization, you can use either Power BI or Grafana or even Datadog. And lastly is on ML flow for the continuous learning and autonomous improvement. So this pipeline is required for your agentic AI system building and deploying and improvement. Okay. So this is a slide for data ops. I will take a little bit more time. Sorry, Mr. Arshid. In terms of collaboration. And this is a slide for the DevSecOps. You will implement DevSecOps at the end. At the end, after you implement data ops and DevOps, data ops, and AI ops. Okay. Now, the most important slide for today is this one, which is your ML ops, LLM ops, and agentic ops ecosystem as a part of your journey towards continuous improvement for your AI ops ecosystem. So this is AI ops. AI ops consists of machine learning ops, deep learning ops, LLM ops, and agent ops, for example. So I believe that you know already LLM ops. Is anyone in the audience knows have implemented ML ops before? So usually, even for your simple application of machine learning, where you are doing the prediction of a machine, you need to implement ML ops ecosystem where you are having continuous automated pipeline, getting the data, cleaning the data, giving to your machine learning models to train, test, deploy, and monitor. So same goes for your LLM ops and also for your agentic ops. I will focus on agentic ops, where you have defined and collect the data, user logs and behavior, pre-process the data, normalize and select. And by the way, LLM ops will be part of your ML ops will be part of your LLM ops, and LLM ops will be part of your agent ops. So you have a multi AI model ecosystem and operations. Coming back to agent ops, after you have pre-processed the data, clean the data for as a perception, then you will able to select a tool, which is your LLM ops, which is your large language model. You build a multi-model agent, the 5 and 6 models that we have discussed in the beginning. And then you allocate a task, automate them, deploy them, and get a feedback in terms of continuous improvement in this regard. So that is the brief overview of agentic AI system in terms of how we can able to develop them. In terms of strategy, there are different type of AI agents, and how we can able to integrate them in XOps, which is your DevSecOps, data ops, and AI ops ecosystem. Okay. Any questions? I will be more obliged before we move to Mr. Arshad. Okay, if there's no question, then I would like to extend my sincere thanks. If you have any questions, you can feel free to message me anytime over here or even email us. Okay, thank you very much. Over to you, Mr. Arshad. Mr. Arshad, are you ready?
Yes, I am. Let me share my screen. Can you hear me?
Yes, loud and clear.
Okay, great. Let me share my screen. Hello, guys. Good morning.
Good morning.
Before I start going, I just want to share the link to the Jupyter notebook that later on I will be going through. And if you guys, if anybody is interested, can start setting up on your Colab account. Here's the link. Okay, I'm gonna share my screen now. Entire screen. Yes. Can you guys see my screen? Hello, can you guys see my screen?
Yes, sir.
Oh, is a presentation screen, right?
Yep.
Okay. All right, let's get started then. All right, guys. Thank you, Datalytic.ai, for inviting me to this presentation and giving opportunity to share some of my knowledge with the rest of the folks. And let's get started. So today's session is a brief session that actually I'm trying to introduce agentic AI from prompts to autonomous intelligence, right? So what I will be going through is, or basically what going to be the key takeaways from this presentation will be that you will understand how an AI has evolved, very preliminary kind of history I will give, then what an AI agent really is, and what is a context and tool matters, and a step-by-step illustration. These are the things that I would like you to take by the end of this session. My desire is that you will understand how the basic AI agent works, what are the key ingredients of an AI agent are, basically giving you the very high level overview of the inner working of an AI agent. I will not try to go into the technicality details of the AI agent itself, but will try to remain at the very high level, at the conceptual level, so that majority of you can understand what exactly gone or happens behind the scene when an AI agent runs. All right. So about myself, my name is Arshad Mahmood. I am a senior staff engineer at Intel Malaysia. I'm a IEEE senior member, professional technologist as well. And what I do at Intel, more than 18 plus years of software engineering, with lately for the last 5, 6 years, focusing on the AI related stuff, enabling OpenVINO, driver development, and GPU performance related stuff I do at Intel. And also, last year I was a mentor for Intel AI Deep Learning Certification Program, internal program to guiding engineers in applied AI. I do regularly write articles at medium.com, and my LinkedIn profile is over here. Besides that, I used to do skydiving, some flying, those kind of things. As a side hobby, I do that. Okay, let's go to the presentation itself. This chart showcase the evolution of AI through the decades, right? Maybe some of you already have an idea about this, but just as a refresher, I thought of highlighting this here. Okay, the the very first AI boom. So AI basically started with at 1950s with the invent of computers, mainframes at that time. AI was born very rudimentary, very plain kind of AI concept were there, mostly like a reasoning, logic, problem solving. At that time, the first AI programs were born at that time. Very simple, very not really that complex. That boom didn't last longer because there was not enough compute power, and there was not much data available at that time. So it's just that boom was quickly die off for the winter soon after a few years. And then in 1980s, around that time, the second wave of AI was born. It was the rise of expert systems and rule-based intelligence for specific domains, mostly like, for example, medical space. There were if-else kind of rules, like if the patient has this symptom, those things, then most likely it will have this kind of diagnosis. Those kind of very expert level kind of systems. Although they produced some good results, there were some good examples of this implementation, but also that didn't go much further. Why? Because even at that time there was not enough compute power was not there, and the data was not that much. And then the third AI boom started somewhere in 2000 in this century, start of this century, with some good articles start coming out where the machine learning and deep learning transforms the perception and prediction. One of the key reason was the very good from excellent GPU power started to emerge, plus the compute power, and also because of the internet proliferation, a lot of data was started to available for everyone to start training their models, like deep learning models, YOLO, ResNet, those things. And that actually gave this third AI boom, which was mostly dominated by machine learning and deep learning. And then lately, in 2020s, around that time, the generative AI revolution started happening, where which is actually stems from machine learning to deep learning to generative AI. And now with that, AI now creates, because previously with the third AI boom, AI was it only predicts, like whether it's a dog. You give a picture, it's a dog, it's not something, or some semantics like. This is a text, whether what is the mood of that text, is sad, happy, those kind of things. So it just predicts only. But now with the generative AI, AI now can generate text, code, and images, just like with human-like fluency. So that's where, and now we actually at the verge of the very next boom, which is the AI agentic boom. So from creation, we are actually going towards action, which is the crux of this whole talk that I'm moving forward. We're going to talk about this. So the leap from traditional AI to generative AI. Old AI could see and recognize, like identifying faces, objects, or spoken words. The third era, which was the deep learning era, which helped AI learning from lots of examples, improving accuracy in visions and speeches. Then move to the generative AI, now can create, write text, draw pictures, even compose music, and generate code. Excellent music. Then I was listening to some music generated by AI. Excellent music, huge potential over here. So now, meaning we no longer just teach AI to answer, we actually are asking to imagine it. AI has learned to see and understand, and generative AI learned to imagine. Now, as I said earlier, that now we are actually in the verge of another era that is taking place, is the agentic AI, AI agents. From generative AI, we are moving towards AI agents. And if you recall that generative AI is mostly about prompting, it means give a good prompt, get a good answer. See, so now why prompting alone isn't enough? Means why not we just stick with the generative AI? Why the agents are needed? What niche they are trying to fulfill? So the generative AI actually creates, as I mentioned earlier, but it does not truly understand, remember, or act, right? So generative AI can text output, image output, code output, fine, but there's no persistent memory, no action, no autonomy. Generative AI can create wonderful emails, wonderful texts, everything, but it cannot drive things. It cannot do action. It cannot take action, and that's where we are moving towards agentic AI. So think of generative AI is like a genius student, which is full of knowledge, great at explaining things, but can only talk or write. Doesn't talk, just only that one, right? So agentic AI is basically when you give the student, that genius student, tools, which now using those tools, the LLMs or generative AI can build, experiment, and act on what they know. It's a shift from knowing to doing, and from answers to action. Okay, so tools here in the illustration I've shared the tools like hammer, but basically in the domain of AI agents, the tools have a different concept, but basically they do the same thing. The tools are used to accomplish things. So what are tools? Tools are external capabilities that model can propose. They are not part of the language model itself. And the LLM uses language to decide when and how to use a tool based on reasoning. Tool is an external function. It mostly tools are external functions, APIs, code modules that actually perform an action. So tools are not hosted inside LLMs, not inside. They are external, hosted by somewhere else. But LLM can suggest that, hey, I want to run this tool. Once you run, give me back the results. I will use the results to answer my query. Something like that. Later on, we will dive deeper into how this whole circle goes on. So let's take an example. Generative AI without tools, smart but empty-handed, right? So let's say if I have a LLM, a local LLM. I have Llama or some Mistral I have loaded in my local machine, and I'm giving a prompt. I want to know that how long it will take a cheetah to cross the Golden Gate Bridge at top speed, right? That when I give this to LLM can guess, but doesn't know what, cannot answer, because at the time when the LLM was trained, maybe that information about, in order to actually calculate that information, what need to be known, how long is the Golden Gate Bridge and what is the top speed of cheetah. Probably these two informations were not given at the time of training the LLM, or even if it's given, it's LLM cannot remember each and everything. So therefore, but the model most likely will respond like, hey, I don't have information about the cheetah's top speed or the bridge length, right? The as in the previous slide mentioned, that consider LLM as a genius student that can write, can do everything, but it does not know much about outside of the world. So this LLM knows language, but not facts. It cannot fetch real data or perform calculations effectively, right? Because mostly largely it's a language generation, language creating models, right? No tool, no context. So that will be the answer, let's say, with this thing. Now let's go to with the supplied context, AI can reason correctly. Now in this second example, when we create the prompt, in the prompt we also can, let's say we share that two information. A cheetah's top speed is about 120 kilometer per hour, and the Golden Gate Bridge is about 2.7 kilometer long. We provide that whole information, and with our question afterwards, like how long it will take, and now the LLM will be able to answer. LLM is smart enough to conclude from the given context in the prompt itself, that hey, at 120 kilometers, it would take about 81 seconds to cross the 2.7 kilometer bridge, roughly 1 minute and 20. This is the answer I will get from my LLM, right? So it's all about the context. Now in the prompt up here, in the prompt, the context word, the word context is just given over here. Even if you don't give the word name context, just these two information in our prompt, the LLM is smart enough to use that information to come up with an answer, right? So it's all about giving extra information to to the LLM to come up with the answer. And how to give that information? Basically, it's through the tools, using the tools, right? The LLM can reason well, but only when it has the right information context. Without context, it just guesses, right? And with context, it actually uses that information to reason and come up with a logical answer. What if we can use LLM itself to find what information is missing and use external tools to bring that context information and feed it back to the LLMs so that it can think clearly, right? So, as I said, LLM are the models are very generic, right? They can be used in any context with any domain, right? So, if let's say if we want to use LLMs for our domain, what we can be what we can do, we can use LLMs to tell us which tool they want to execute. We will execute for them and give back the answer in the next prompt, and they will use that answer to come up with a. So all that cycle is once is nicely managed, come up with amazing results. Actually, produce amazing results. And that's why the AI agenting is so much fascinating and everybody's talking about, right? So this is what, so if we are able to create such a loop where we use LLM to suggest us what tools they want to run, and we run those tools externally outside of LLM and give back the results and let LLM to come up with an answer and give back us the final answer. All that thing, that infrastructure is called as AI agent. Okay. Adding tools, giving AI the power to retrieve facts, right? Tool can act as a bridge between LLM and knowledge. So as I said, LLMs are very generic. They are work in silo, means they don't have access to the external world. And that's where the tools are there to bridge that gap between knowledge and LLM. So tools can be used to provide relevant knowledge in the prompt text itself to LLM to produce results. Search tools, for example, searching from web, find the bridge length via web. Math tools convert speed and calculate times. Knowledge APIs retrieve factual data. In the context of manufacturing, let's say if you have some sensor data, sheets, fact sheets, something, we can use tools to read those data and provide that to LLM to come up with the very good use case creation. The LLM decides which tool to call to get info, but cannot call them directly. Again, this is very important that LLM does not have access to any, means cannot call any tool. They don't have access to tools. What we do, we tell them we do have these set of tools. You decide which tool you want to run, and we will run it and give you back the results. That's what all is just about. And tool feeds the context. LLM forms the reasoning. So who calls these tools? Means who run this whole show? Who's the main brain behind this show? Say, AI agent is not a single model. Okay, one more important distinction is that AI agent is not a single entity. Basically, AI agent is a concept. Is a concept that is built using three main players. The number one is the orchestrator, the brain that manages communication, coordinates reasons, and decide what to do next. Means I just know I was mentioning about the loop, the who actually puppeter, who tells LLM, hey, I want to do this, and then gets to run the tool and everything. Who does that? That is the orchestrator, is the one that does everything. Then the second most important ingredient in an AI agent is the LLM itself, which performs reasoning, understanding, and language-based planning. And the third is the tools that are being either hosted within the orchestrator or outside somewhere in the network, and through some MCP or some kind of common standard interface, they are being called by orchestrator to get the results. So the AI agent is a combination of an orchestrator, the framework, that like for example, LangChain or Llama Index, those are orchestrated. That one, the LLMs like or ChatGPT or Mistral, Llama 3.1, those are LLM. And the tools. The tools are very custom made. The tools functions that are hosted uh, and either locally or at remote and call to get relevant data. So the AI agent, the brain that plans, reasons, and acts. So an AI agent is not a single. Just to reinforce that AI agent is not a single model. It's a system built to act autonomously towards goal that planning and reasoning. It combines three key components: orchestrator, LLM, and tool. And orchestrators actually sits at the center. It sends prompt to the LLM, interpret tool calls, manage memory, and drive reason, act, reflect to the loop, the whole loop of getting. Because when the AI agent runs, it does not ask LLM only one time. There is multiple times it asks with the refined data and everything. So that whole loop, or and concluding to the final answer, is run by the orchestrator. Okay, now here this is a interesting illustration animation I made to showcase what exactly happens behind the scene. So here at first, for example, this is a query that I for example I want to know the same question I said earlier. How long will it take a cheetah to cross the Golden Gate Bridge at top speed? My full prompt will be like, you are a helpful assistant. Following tools are available for you. Web search, use for searching web for info. These are the tools available. And my question is this. The user is my question. This whole text I'm gonna feed to LLM. My LLM could be Llama, could be Mistral, could be ChatGPT. This will go to the LLM. Then LLM will decide, okay, LLM will think internally, that because nowadays the LLMs can make thinking, they are being trained to handle that kind of thinking process and tool calling kind of logic. I need to know two facts to answer this. That's what LLM will think. The length of the golden, because from the query, it will break this query into two questions, two requirements. The length of the Golden Gate Bridge, the top speed of a cheetah. These are the two things. So it will send a request back, tool request, hey, I want to do a web search of Golden Gate Bridge length, and also want to search for cheetah top speed, right? This will go back, this output or results of the first query will go back to the orchestrator. Now, the orchestrator, what it will do, it will extract the tool request from here and call this web search tool function with this text here, which will go to the tool server. The tool server will run the web server search either through behind Google or DuckDuckGo or any other choice of search engine. And the results will be few lines because the tool will make sure that not too much info is sent back. It will only relevant. Golden Gate Bridge is 2.7 kilometer long, and the second result for the second query will be cheetah's top speed. It will be given back to the orchestrator. And then now what it will do, the orchestrator will add that information into the system context and again send the same query that, hey, how long it will take cheetah to cross the Golden Gate Bridge, right? This will be given back to the LLM, and LLM will now, since it has all the information, all the relevant information that was needed, it is smart enough to conclude the final answer, which will be roughly 1 minute and 20 seconds, which will be given back to the orchestrator, right? That will be the answer. So that's how this whole thing will work. Means the LLM does not know about cheetah's top speed. LLM does not know about the other things, and even LLM did not know about the web search tool that we given in the context, right? We tell LLM, hey, these are my tools. You can suggest these tools, and we will call those tools, give you back the answer. So LLMs is this means we can use this kind of model for any kind of scenario, even for example in manufacturing. We can make this LLM to suggest based on our sensor data or those things. We can give tools to LLM. Hey, these are the tools to fetch sensor data. So I want to know the health of my whole system and everything. Suggest so LLM can suggest, hey, call these tools for me to get sensor data from these items, and I will make a report for you. Something like that. So do you see the power of this whole thing? Very generic, doesn't tie up to any domain. And once done nicely, it can create huge, excellent results. And that's where the orchestrator, how good is an orchestrator, how good is the LLM, all are very important in this whole cycle. So who provides agent logic? The framework, the architect. It provides the agent structure, how reasoning, tools, and memory connect. It defines orchestration logic, the reason, act, and the reflect loop, the whole loop. That I just know the message passing I shared in the previous slide. That is the loop that is going on. It manages tool interfaces and memory storage, integrates with the different LLMs. It like OpenAI, Llama, Hugging Face, whatever the user has selected to interact with. And the framework gives the agent its mind, the logic that makes it act autonomously. So again, LLM cannot run tools, cannot run execute code. It's the orchestrator, the architect that runs it, but LLM will suggest. So orchestrator uses LLM's power, the intelligence power, to suggest what tool to run and give back the results and get everything ready or produce effective results. So you can consider a framework basically as an operating system for the agent. Again, the key concept here, one of the key concepts, earlier concept I want to share, the AI agent is not a single entity. It's a combination of orchestration, the framework, the LLM, and the tool. All they work together to create an AI agent kind of behavior. Some of the popular frameworks, Mr. Imran has already given a very excellent overview in the previous slide, in the previous presentation. I wouldn't go into detail, but some of them are LangChain, Llama Index, AutoGen, Fast MCP. Basically, Fast MCP is not a framework; it's a framework to call tools. Then Haystack and Meta. These are the popular ones. Are the top few. Okay. Now another key thing that I want to, LLMs are trained with agentic support. What does it mean? Means most LLMs aren't more agentic. As you know, LLMs that are generative AI models that just predict the next text. What going to be the next text from the, you give some text and expect it to generate from there the next set of tokens, right? They are trained to predict the next word only, not to plan, act, or use tools. So what does agentic support means? A model is trained or fine-tuned to understand multi-step reasoning and goal-oriented dialogues, right? Where means in the illustration earlier I showed where the orchestrator was sending text and then LLM was suggesting I want to run this web search tool and then given those back and then come up with a final answer. All that means these LLMs must be trained to be aware of that kind of go and back kind of conversation with the orchestrator. So that's once they are trained with that kind of scenario, that is called agentic support. And they follow structured plans or tool call formats. Now, the animation I showed earlier was an older way of calling agents, React mode, React kind of way. Now the modern agents are being developed using the JSON kind of style tool call formats, which is more robust, less means have eliminate a lot of limitations with the React model. I won't go into detail because this is just a short presentation, but the the idea is that now the AI agenting is also evolving. So previously the React one, now going towards tool call. Still React is good, still better for in some of the use case scenarios. And the training, the AI agentic support in LLMs basically means it will work smoothly with frameworks and APIs that provide memory or action. Examples are GPT-4, Claude, Gemini, trained for fine-tune with tool use awareness. Also, the local models, the local run models, mostly open for Llama, Mistral need prompt or adaptive training for agentic behavior. Right? So agentic ready LLMs can reason and decide what to do next, while traditional LLMs only generate text, right? So that's the key difference. Means the regular generative models just generate text, but agent ready LLMs knows that they are aware of that loop, and they are able to assess and collaborate with the orchestrator in a nice, better way, in a more friendly way. Commonly used LLMs for agentic AI, some of the commonly used models are such as the GPT-4, open from OpenAI, is a high-end performance, strong for reasoning and tool use. Claude is also very popular, mostly it's used for coding in GitHub Copilot, excellent uh, models. Llama 4, more open access, strong multi-model context windows. Quen, Mistral, it should be there. I didn't put Mistral. Mistral is very strong in agentic AI. Okay. Tools, the agent's connection to the world. The agents, again, just to rephrase, tools are what let AI agent to do things like searching the web, looking up data, using a calculator, or sending an email. Without tools, an agent can only talk. With tools, it can act, right? And again, just to emphasize, tools are not run by LLMs. Tools are run externally by the orchestrator, but agents, LLMs, are can suggest in the results that, hey, I want to run this tool, please run for me and give me back the results. That's how the whole thing works, right? Um, another Here's a problem. Each AI framework connects tool in its own way. Right? LangChain interacts with runs tools within its own way. A tool that works in one system might not work in another, and it's hard to make them talk to each other smoothly. And that's where the MCP, the Model Context Protocol, comes in. It was designed by Entropy, the Entropy provider. What they did that that hey, let's come up with a standard to call those tools. Let's host those tools in a server, and all the other frameworks like Llama Index or LangChain, they call those tools through a standard MCP protocol, which will basically one day our to be using tools from one vendor provider. Next day we can change without any issue to another provider, since both of them are using MCP, and that's the benefit we will get as long as the tools have the same uh, signature, the parameter, everything should be able to use without any issue. It actually gives everyone a common language, so tools, agents, and frameworks can work together easily and produce awesome results. So this is something just put over here because this is very key area or very hot area buzzword that you might be hearing about MCP. That is what the MCP is not. It's not AI agent. It's not LLM. It's not orchestrator. It's just a protocol that helps orchestrator to talk to AI to talk to the tools and get the results back in a more common friendly way. All right, this is the last slide from AI agent to agentic AI. The next leap. Imagine you have a team of smart assistants, each good at different things. Each one can research, another can plan, and one can write, and another can check results. So when multiple and each agent is specializing in own way. We just only one thing is expert in that one thing. But when multiple agents work together toward one goal, that is called agentic AI. Basically, agentic AI is a combination of multiple agents work together nicely to come up with a bigger goal, to achieve a bigger goal. Each agent reasons and plans and act using tools. They share results and coordinate automatically. So agents talk to each other. So output one agent, again, each agent is a combination of its own LLM, its own orchestrator, its own two set of tools. And when that combination, they work together, they each of everyone handling one part of the problem, but at someone at the higher layer get the results from one agent, feed to the next agent, to the third agent, and all. That whole combination is called agentic AI. So agent is not a single model. It's an ecosystem of coordinated agents that think, act, and learn. All right. So this was the all what I have to say. The goal was to give you a very high level understanding about what happens behind with AI agents. When we talk about AI agents, what exactly is going on, and we will go and see in action just now in a short while. The Colab Jupyter notebook that I shared, I hope some of you have already opened up and set up on your machines. Let's go through that Jupyter notebook and give you a good idea what exactly it's. Let's see them in action. Before we go, any questions? Nope. Okay. Here is. Let me share back the screen. Can you see my screen? I just reshare again. Okay. All right. This is a AI agent example. What it does, it basically uses a local LLM to suggest if there is any wrong with the sensors, with the machine operating. We are stimulating sensor data over here. We feed that sensor data with some temperature and throughput variables to the LLM and let LLM give us the final conclusion what need to be done for the machine. If everything goes fine and is going fine, or if some steps need to be taken. So that's what this agent will showcase. Very rudimentary, very kind of simple implementation, but just to give you an idea what exactly is it. So here, first of all, need to change the runtime. So runtime is chosen T4 GPU, right? And let's install LangChain, the specific version, because now the LangChain has changed to new way of doing things. I just stick with the existing way of APIs for clarity. Okay, restart session. And let's run Olama. I'm running Olama behind the scene. Meanwhile, this is going on. I have a local setup here as well, doing the same thing. From there on, exactly the same thing is there. Then base. These are the imports for the agent, and this is the baseline data. Basically, these are existing data, simulated data that shows what is the good results, the baseline data that we should be complying, the agent should be complying to. Okay, these are the tools now. Tool is get machine efficiency, which actually here it is getting efficiency from the given data, which will be given as a parameter to this. But in a real world, this can be hooked up to sensor inside that tool. It will call a sensor API to get the data, real-time data from the machine, and sends back the data through as a string variable to the, because we are talking about generative AI. So generative AI is all about strings. So we need to convert even the numbers into strings for LLM agent to digest. Then this tool is to detect anomaly. So the AI agents will use this, will provide the data to it, and it will return back uh, in a very simple way whether this data is beyond or within the specs or something. And then the recommend action is all if else over here, that hey, if the efficiency is less than this, and then do this, or this means this. We are actually here, we are returning a text, and that text will be digested or interpreted by the LLM to come up with a final conclusion. So we are in a very descriptive way, we are telling LLM, say if this is happening, this means this. Then there's some dump for debugging, for printing. Here is the agent setup. We are running Olama locally, where with the Mistral 7B temperatures callbacks. This is defining the LLM node that I shared in my earlier presentation in the one of the slide, that LLM was residing this side and the tools were that side. So these are the tools that I have, and this initialize agent call from LangChain is connecting both of them, tools and the LLM together, using zero shot React description. I won't go into detail of this all this thing because it's a very high level concept kind of session. If let's say if this multi-day kind of training, those things, definitely we go each and every detail of these things, right? So here is now the agent has created, bounded by this LLM and with this tool, with this sum of the parameters. Now once it's done, our agent is there. Now we're going to invoke the agent with our current data. This data, again, I mentioned, we may get this data through the sensor runtime, or even we can ask LLM to give a tool to LLM to get the data, and LLM will propose, hey, call this tool to get the updated recent data, and I will then query from there. So anything can be, whatever the user will feel comfortable can be done. Now the LLM is running behind, and it will showcase the different steps that are being performed. This is the thought process from LLM. First, I need to calculate the average machine efficiency. To do this, I will use the get machine efficiency function. Why? Because I did provided LLM in that, hey, you can use this get machine efficiency, and LLM is now using, I want to use this. It gave me, it actually in the results, it returns, I want this action with this action output. This will be passed by the orchestrator, LangChain. Okay, this is not found in Colab. Let me get back to you on this one. And then it will the orchestrator will run the tool, get machine efficiency, and gives back the result over here, and then call again. And this thought, the now LLM will use that result. Oh, now that I have the average machine efficiency, I need to detect anomalies in the data. For this, I will use the detect anomaly function. Again, this all is being generated by the LLM. This all being this is the thought process going inside the LLM based on the results that I'm providing, based on the results that the orchestrator is providing back to LLM. Now it will ask, okay, now I have the efficiency, everything. Now I want to detect anomaly. Here's the action output. Take this data and call this tool. The observation, the orchestrator will call this detect anomaly on the host machine and will give back this result. The temperature is anomaly, true. Throughput is okay. No anomaly. And then LLM will use that information Since there is anomaly detected in the temperature data, I will now recommend actions based on that data, right? Recommended actions are efficiency 90 through this temperature anomaly detected, inspect cooling system. And now with that information, LLM will make the final answer. It will specifically tell that this is my final answer. Given the machine performance they provided data, the average machine efficiency is 90%, blah, 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 all those things. And the final recommendation is that the average machine efficiency is 90. A temperature anomaly has been detected in one of the data points at temperature 66 degree. It is recommended to inspect the cooling system of the potential issue. The throughput does not appear to be an immediate concern as no anomalies were detected in the regard. Throughput is okay. Let's say this was a bit higher. Let's say if I bring back to 46, and now what will this means? Everything will be inspected. Let's say if AI agent is able to what it will suggest. Now you see the temperature falls, throughput falls, no anomaly is detected. The tool hasn't detected any machine operating within normal range. So nothing need to be done. There's no detected anomalies in temperature or throughput. That is what is the LLM has suggested over here, right? And let's say if I want to observe the what was the prompt was being sent to the LLM itself by the thing. We can do adding use dump functions. These are debugging. You want to see all the conversation that is being going forth between the AI between the orchestrator and the LLM. We can see over here. We can have a look at it. See, here is the LLM prompt sent to the model. Prompt. This was the total prompt that was being sent. The model output was this, and then the LLM prompt. This output was this machine efficiency was executed. This was observation, and in the next observation, this was sent back to the next prompt to the model, and from there on everything. So basically, by this enabling this dumping this verbose mode, you are able to see how does the two orchestrator and LLMs are talking and how this whole thing is going behind. Basically, very good for getting a full idea about the communication that is happening between the two things. Okay, so that is what this is a very this was a very simple kind of example, but you may use to bring this example to more sophisticated by adding more tools that tweak it to your own personal kind of use case and run it. Yeah. Okay, the question came up. This not found in Colab. What exactly? Sorry, what exactly you meant by not found in Colab? Means not able to clone the repository. Uh, can you please elaborate? Anyone with the link? Actually, I have copied that. And anybody clicking on that should be able to have access to this. And same, whatever I showcase in my local Jupyter notebook is able to get the same output over here as well. This is the output you're gonna get. Okay, maybe in your offline you can give it a try, and once you have free time, just go through, tweak results. Let's say change values over here, or add new tools. Maybe add some subtraction, addition tools, or some other tools, and get LLM and see how LLM is smart enough to suggest the right tool for you to run and get the results back and see. And also, right now I'm using Mistral here. You may use Llama and see how the Llama behaves. What Llama, how which one is accurate in interpreting all this or cooperating in a agentic way with the orchestrator. All those very fascinating, very excellent kind of activities that you can perform. Okay, I am done. We are 4 minutes left. Any questions? Any questions, guys? I am not able, if you are asking, I'm not able to hear. Dr. Imran, I'm done. You may proceed. You are on mute, Dr. Imran. Hello, anybody there? Okay, guys, I'm done. Thank you. And I hope this short presentation should have given a very clear idea or clarity about what AI agent is and how they do work internally. Basically, there are many versions or many kind of formats are there, but they work together. The basic idea is the one I shared